Dear students, welcome to the video lecture series on vocational electronic science. Current topic is sources of power. This presentation is created and narrated by Hemant Satpute, teacher, Department of Electronic Science, Fergusson College, Junior Wing, Pune 4. In the lecture number 15, under the topic of sources of power, we are going to discuss some numerical examples on voltage source and current source. Let's begin. First example, figure shows a DC voltage source having an open circuit voltage of 2 volt and internal impedance of 1 ohm. Obtain its equivalent current source representation. Now the solution. If we short circuit the terminals A and B of the voltage source, then the current supplied by the source I under short circuit condition will be equal to Vs upon Rs, that is 2 upon 1, that is 2 ampere. So in the equivalent current source representation, the current source is of 2 ampere and it will be connected in parallel with an impedance of 1 ohm. So the required equivalent current source representation will be 2 ampere of ideal current source is in parallel with 1 ohm of internal impedance. So I hope the procedure is clear. Let's move on to the next one. Obtain an equivalent voltage source representation of AC current source shown in figure 2.18. So here a current of 0.2 ampere has been shown connected in parallel with an impedance of 100 ohm. We need to convert this into an equivalent voltage source representation. So let's find out the open circuit voltage across the terminals A and B. So open circuit voltage across terminals A and B will be given by the product of Is into Zs. So 0.2 into 100 will give you 20 volt. So this 20 volt, this will be the value of ideal voltage source in the equivalent voltage source representation, and the voltage source impedance Zs is put in series with the ideal voltage source. Thus the equivalent voltage source representation will be 20 volt AC supply is in series with 100 ohm resistance. I hope this point is clear. Let's move on to the next example. In the circuit, an AC current source of 1.5 milliampere and 2 kilo ohm is connected to a load consisting of two parallel branches, one of 10 kilo ohm and other of 40 kilo ohm. Determine the current I4 flowing in the 40 kilo ohm impedance. Now convert the given current source into its equivalent voltage source and then again calculate the current I4 in the 40 kilo ohm impedance. Check whether you get the same results in the two cases or not. So I hope the problem is clear. A current source representation is given 1.5 milliampere 2 kilo ohm connected in parallel. We have to, and this is connected to a load consisting of Z1 and Z2 in parallel. Z1 is of 10 kilo ohm, Z2 is of 40 kilo ohm. We need to find out current flowing through 40 kilo ohm. First by converting this current source into voltage equivalent and then find the current. And secondly, directly as it is by current source representation, let us find out the current through I4. Solution. Let us first determine the net load impedance that is connected across the source terminals A and B. This would be the parallel combination of the two impedances. So ZL will be equal to Z1 parallel Z2. So Z1 Z2 upon Z1 plus Z2, that is the equivalent impedance. So that comes out to be 8 kilo ohm. Now the circuit of figure 2.20 can be redrawn as shown in the following figure. A net impedance of 8 kilo ohm is shown to be connected across the source terminals A and B. So 1.5 milliampere in parallel with 2 kilo ohm. This is the current source representation and this is connected to a load of 8 kilo ohm. It is clear that the current Is divides itself into two branches, one consisting of Zs and other consisting of Zl. One consisting of Zs and other consisting of Zl. So therefore current I2 is given by I2 is equal to Is into Zs upon Zs plus Zl. Substitute the values and you will be getting 0.3 into 10 to the power minus 3 ampere or 0.3 milliampere as current flowing through Zl, that is I2. Again, look at figure 2.20. The current I2 divides into two parallel branches. That means again we are switching to original one. This I2 current is getting divided into two branches, I3 and I4, one through 10 kilo ohm and other through 40 kilo ohm. So the current in the 40 kilo ohm impedance can be determined as follows. I4 is equal to I2 into Z1 upon Z1 plus Z2. That is, substitute all the values and you will be getting as 0.06 milliampere. Now we shall solve this problem again following another approach. Here we convert the given current source into its equivalent voltage source. So open circuit voltage of the given current source is given as Vs is equal to Is into Zs. That comes out to be 3 volt. Therefore the equivalent voltage source representation will be an ideal voltage source of 3 volt in series with an impedance of 2 kilo ohm. We can connect the net load impedance ZL of 8 kilo ohm as calculated above to this voltage source as shown in figure 2.22. So effective voltage source of 3 ideal voltage source of 3 volt connected in series with 2 kilo ohm, and this voltage source is now connected to an effective load of 8 kilo ohm. So this circuit is a single loop circuit. So the loop current can be calculated by applying Kirchhoff's voltage law. So 3 volt is equal to current flowing through it multiplied by the total resistance, and so total current will be equal to total voltage upon total resistance, that is 0.3 milliampere. So 0.3 milliampere is the total current. Now note that the current I turns out to be the same as I2 of figure 2.2. Now this current gets divided into two parallel branches here of the load impedance ZL. So current through the 40 kilo ohm impedance will be I4 is equal to I into Z1 upon Z1 plus Z2, and that comes out to be 0.06 milliamperes. This is the same result as obtained earlier. So thus we find that solving of an electrical circuit gives the same result whether we treat the source in the circuit as a voltage source or current source. However, as we shall see later, the solving of a particular circuit sometimes becomes simpler if we treat the source as one type rather than the other. That's all for today's lecture. Stay tuned for next video lecture in the series. Please do visit my YouTube video channel FYJC Vocational Electronics for all the video lectures on different topics in this series. Subscribe, like, share and stay tuned.